Hello everyone, very good evening and welcome to the session. And we are discussing Pharma Analytics course, and yesterday we have completed the theory part of decision tree. So when we are talking about decision tree, the first and the foremost thing what we have understood is we want rules, classification rules here for particular business problem. So we want a better decisions with good classification rules, which is going to help us to take a better decision. So yesterday we have understood that we have 3 nodes, right? And it is nothing but we are saying that it is an inverse tree structure. So what is this inverse tree structure? It is the opposite of your tree. Generally, tree starts with root, right? Then you have your branches, and then you have your leaf. But what we are doing is leaves are nothing but here. Leaves are your terminal nodes. Okay, leaves are your terminal nodes. So where your tree is going to end, that is your leaf node. So that leaf node will be a label. So it is whether it is drug prediction, dosage prediction, right? Based on you want to predict dosage or this much amount of dosage should be given for a person who is suffering from a particular, we can say symptoms could be like this, right? Symptoms are like, he is a diabetic, right? What is his BMI? What is his age? Right? Maybe they even consider weight, right? They consider if it is critical, they even consider thyroid. Given all these inputs, right? Whether we have to find out all these are important or not. These are all our symptoms are important, so that we have to give him anesthesia ml in ml. So what is the amount of anesthesia you can give him, right? So what is that you are predicting here? ml in the sense you are predicting numeric. When you are predicting any number, you can also use a decision tree regressor. You're using decision tree regressor. Given symptoms like this, different symptoms, and your prediction is happening with drug, given different inputs, all the diagnosed reports, right? Whether he is suffering from type 1 diabetic or type 2 diabetic, right? What is his heart rate? What is the cholesterol levels, right? Given all this information, you have to give him the best drug, the best medicine here. So when you are directly giving a label here, that label prediction here is decision tree classifier. You are classifying it. You have to give him this. So symptoms are the inputs. Prediction happens in numeric, you are using decision tree regressor. Predictions happens in labeling, you call it as decision tree classifier. Okay, then the next point here is when you are working with a decision tree, the tree will grow to the fullest. The tree grows to the fullest. Fullest means it will take all the inputs. If at all your inputs are 50 inputs you take, 50 inputs you take, okay, it considers all the inputs, right? It considers all the inputs. Given these inputs, it will predict. Okay, it will predict. So what is that we have to do now? In such cases, your tree would learn and memorize, it will learn and it will perform excessively good on your data. So what will happen? But a situation comes where when you want, you said definitely when you are building any model, it is a life and risk thing. You have to evaluate, you have to check whether whatever model you have built a decision tree or a logistic regression or it's a linear regression. You have to check whether it is good or bad. Without evaluating, you cannot directly give that particular, can't trust that machine learning algorithm. So what is that you should do? When you evaluate on new data, what will happen? Decision tree will fail. Decision tree will fail to give the best results. It will fail to give the best results on new patients. Why? Because few algorithms will have some pros and cons. Decision tree always fails to give the best results on new patients' data. It can be new patient data or new patients' data here. New data. So what is that we are going to do now? We have to evaluate it. When you evaluate it, you have to check whether your model, your decision tree has learned the patterns, the rules, what you got are good or bad rules. Okay, how well it's able to find out. So what you will do here is, we will take a scenario here, right? You are predicting the drug to be prescribed based on the information which is given by the patient. So this is quite introduction, what we have added. And we have understood that the tree is, the strips are, the stripping of the tree happens based on one particular criteria, which is called as entropy. What is entropy? It is an error content. When you are trying to split based on that entropy, you are calculating information gain and you are choosing the best. You are choosing the best input, which is maximum information gain as a root node, so that you will end up with less number of rules. The path what it is following from root node to your this leaf node is easy, right? So if at all you have any, if you are taking the data now, intersystolic noise is taken. It is splitting into two parts, whether you have an MCI or whether you have a precordial pain. If you have a precordial pain, it is a prolapse. And if it is not this situation, if you are coming to this MCI, you have heart malformations or systolic blood pressure. Again, you are splitting it into prolapse or no prolapse. So what is happening now? Wherever you are having this, you are calling it as leaf node. This is your class label. This is your class label. So this is one of the best examples. So if the patient has some intersystolic noise, right, and MCI and heart malformations, then he or she is prone to a situation which is a prolapse situation. If the patient has intersystolic noise and MCI, there are no heart malformations, then they don't have any prolapse here. So what is the criteria? It is doing same like our British rule. We are using divide and conquer principle here. When all the objects, whatever you have content is there, you are collecting all the content, but the more priority is given to that input, where we call it as the features are taken into consideration with information gain concept. So the selected attributes or the inputs what you take mean the same. They is in a growing decision tree from each branch from that node. Inducing procedure is repeated till you reach your leaf node. So today we'll take one business objective like we have discussed yesterday. the real-time use case where you need to give a drug for a patient who is suffering from hypertension, along with few other symptoms like he is having some pain in the abdomen, nausea situation, vomitings, light fever, and loose stools as well. So he was suffering from this, not on daily basis. He was suffering, but the thing is, he was having 2 to 3 episodes of vomitings, loose stools also 2 to 3 times, and mild fever. So what we have done, we have to give him a proper medicine. Given these inputs, how it is going, what process you will follow here. So my business objective is a person who is having swelling in the feet, you call the pedilodema, right? For 3 months, he is suffering from the pedilodema case. Means you have swelling in the feet. Given that problem and also a little bit pain in the stomach, the abdomen, he also has 2 to 3 episodes of vomitings, mild fever like once in a while like that. So what happened? First, he has approached us. So I have collected the data from the hospital where the variables picked here are definitely once we move to the hospital, we have the patient ID, then we have taken his age, whether he is a female person or a male person, whether he has pedilodemia case, whether he is having blood pressure, what is his heart rate, what is his serum urea, blood urea nitrogen, creatinine, sodium, potassium, and chloride. So all these are, it's a hypertension new case, high blood pressure. Maybe the symptoms even suggest me that he's suffering from a chronic kidney disease also. So what I do is I just want to work with the data. I want to do some plots. So I want to even manipulate the data. I will import these libraries. Import NumPy, import pandas, import matplotlib.pyplot as PLT and seaborn package. I'm saying that in between, if you have any warnings, you ignore. You all know that these are already available. Unless and until you import them, you cannot use them. That is that is how Python works. Okay, so I have pulled the data here. Okay, and once I pull the data using pandas read_CSV, I've just written head count. I want first 5 visualizations. Okay, so this is how the data looks like. This is what I have collected. So given these information by the patient, I have to prescribe him a Silamet or a metoprolol drug. So what happens here when I have collected, the scenario was like, when we have collected, when he has reached us on one particular day, we took his temperature, we took his PR, we took his SpO2, we took his blood pressure, and next day morning also, we under observation, we took his blood pressure again, RR again his SpO2 at different time intervals. Something like, morning 7 o'clock, again we have taken the same count of all the blood pressure, SpO2, PR and RR along with temperature at 8:30 a.m. So the temperature was around, he was suffering from around 100 degrees. And what did we do is we have suggested him for a dolo to 650 mg. But the situation was such a, it was not that much normal situation. Then we have thought that we have to even collect his serum urea. We also took his plasma glucose fasting, that sample also. Then we have collected these respective diagnosis report test is conducted. Then we also thought that if maybe that swelling in the feet, we thought that we even thought that we can go for some liver function test also. So the total bilirubin, the direct bilirubin, indirect bilirubin, and we have taken SGPT test also, SGOT test also, alkaline phosphate test also. We have taken total proteins test. We have taken serum albumin test, serum globulin test, and A by G ratio. So these were liver functionality tests that we have prescribed for the few of the patients were like that. Those were having worse situations, so we have collected this. Right? And we have also tracked his previous record, like past 1 year, what was the treatment given and what was his count of all these tests. So what happens? We have observed that the BP was fluctuating. In the morning, it was like 140. Again, after 1 hour, when we checked it 8:30, it was like 160. It was not normal. And though the tablet was given, it was not coming to a particular normal value. So the severe were there in the food from so many months. So that led to a kind of conclusion that maybe this is not only related to hypertension, there's something else, like, maybe he has to undergo some hemodialysis test, but we cannot call for a decision just like that. So what we have done is we have diagnosed, we just treated him with one drug, right? And we again took the same diagnosis report and could draw some conclusions. So let me discuss that. So first, there is a function called shape. So I have collected 451 people's data with 13 columns. Okay, and yesterday when I told you when we have to work with decision tree, we need to perform discretization concept, where it cannot take few values like this. Right? You have male and female. So all this, well, you have to do that everything should be at least numeric data, or everything should be like categorical data, or we have to perform some kind of pre-processing, which is called as label encoding. So what we will do when we will have to go for this label encoding, right? So that particular function is available in sklearn.preprocessing. So the man of the show is your sklearn. In sklearn pre-processing, we are importing label encoder. Here I have called the function. Okay, I am using this le.fit_transform. I am referring to my data set to this column, which is a sex column. Okay, again, if you observe here, most of the things are numbered. Only the sex column and blood pressure is high and low. For a few people, it is normal also. Given this normal also, their heart rate was not in sync. It was not like normal. So what happened now? We have to even convert the blood pressure column into label encoding. Okay, so what is it I should do? Fit_transform function is there, where I have used the data set name. In the data set, you have a column called blood pressure. Convert it into numeric form. Label encoding, like an order format. So when we run this, right? And sometimes what happens, friends? We cannot get entire data. There might be few missing values here and there in the data. What should I do? That time my model cannot learn properly. Maybe my correct drug prediction might not happen. So there might be few data points missing like this. So what shall I do? If that is a situation. What shall I do if that is a situation? First here we can do imputation technique, like we have to fill in that. But what I have done is I've just dropped that. I dropped all the NA values. Now, given these inputs, predicting the drug, right? Metoprolol or Silamet, these all till serum chloride, I will consider into X variable. Okay, and Y variable will be my output. Right, this is X and this is Y. It's a binary scenario, either this drug or it is that drug. 2. When you have to, when your situation is that you want to toggle between only 2 medicine, right? This works good. Now I'm using from sklearn.mod_selection. You are inputting train test split. I'm splitting my data because I'm giving training on 80% of the data, but to test whether my decision tree, the rules what I got from a decision tree, are they perfectly done or not? Right? Are these decision trees rules are correct or not? What should I do? In that situation, what we have to do is we have to test. So whatever data I have, 450 people's data, whatever I have, on that data only, I want to test it first. Because I'm giving training on 80% of 450. Baki, how many of them are left out? Those things I am putting for evaluating to check. Even before I work with some new data, new patients data. So how I'm going to do that? From model underscore selection, you are importing train underscore test split. Take X, take Y, test size is equal to 0.2, and I'm saying that random set equal to 0. It means that I don't want my train data and test data to get mixed up. I don't want my train data and my test data to mix up. That is my intention. So what? It is a supervised learning scenario where I am using classifier. So how is the classifier applied now? From sklearn dot tree, you are importing decision tree classifier as DT. So this is one man show, as I told you. sklearn is having all the machine learning algorithms, which is like repeatedly we use that. You import a decision tree classifier as DT. So decision tree criteria being Gini, right? Like we have entropy, right? We can also write here entropy. I'll show you that also. So CCP underscore alpha, maximum depth, minimum samples underscore leaf, maximum features is 6. I'm saying that take 6 features only to build a tree. I'm saying that I don't want the tree to grow to the fullest. I'm restricting it. I'm restricting it to grow. So it will take like this. It keeps on growing, growing, growing. What will happen? As I told you, overlearning will happen. Your tree will become very, very smart and it tries to learn the patterns perfectly because it is growing to the fullest. To break the chain here, this is depth 1, depth 2, depth 3, depth 4, like that. I want 8 depths. Okay, after 8 depths, just stop. I'm stopping it. Okay, I'm stopping it. I'll remove all that and also I'll show you how it is going to work. Okay, so anything for any algorithm, if you have something in your hand like a weapon, so that you can do some changes to your algorithm, those are called as hyperparameters. Just like you tune your radio channel so that you stick to one particular number where you get the better sound with very good quality and without any what you call it as buzz sounds like that, you stop there. Similarly, every algorithm also you have to tune. You have some weapons in your hands, like we have a tuner for radio. For decision tree also we have few arguments, few parameters, which will help you to get a very, very good model, very good accuracy, very good prediction. So such things are nothing but these are the weapons for decision tree classifier. You will wonder, you have like 10 to 15 things which you can change from your end. So I'm running it. So this is my initialization. Now I'm fitting it. Fit it. Right. Now let me show you how the tree looks like. So how to do that? I'm just taking from sklearn, I'm importing tree dot plot underscore tree. This is the explanation. This is your tree. Okay, let me show you. This is very big. Let me show you with a small. I restricted it to grow to the fullest. I told depth is should be, I think it's 3 is what I gave. Yeah. See, this is 1, this is 2, this is 3. Right? This is 1, this is 2, 1, 2, 3. So we are not growing it to the fullest. What if I remove this? Okay, I can remove this because it is, if you don't give also, it will work because it is a tuning parameter. It takes time. See, this is a full. So the path it is following from the root node to reach to the root node, say leaf node. Right? Root node so to leaf node. This is a path. So you have got this orange wala. See, you have come here, you have to come here, 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 here. There is no further, see like this, there are no further arrows, no split happening here. So many, so much rules, so many questions to be answered by the patient, so many inputs are required. That's the reason we can restrict this. And when you ask to learn the pattern, decision tree will work number 1, the best. But when I give a someone, it's not part of the data I have collected. So tomorrow when 452% comes, right? Here I have only 451, if I'm not wrong. If 452 or 53% comes into picture and I take his data and I take the symptoms, what is that we do? Your model may not work properly. Maybe we don't know. That's why we are not trusting, right? We are evaluating. So this is a tree I got. Then what will I do? I have separated my data into train and test split. So I just passed my X train. Now I'll pass my X test to predict. Model dot predict X test. Okay. So this will give me the accuracy of the model. See, it is working 79% good. There's out of 100% accuracy, your model is working good only for 80% times it is good. Rest of the times it is not working fine. Right? That is this. Now, what happens now? If you want to improve this, how will you do that? Your model is only predicting 79% good. It might not be correct. Sometimes it will not be sufficient sometimes for few scenarios. So what we can do is we have to check and do some changes here. Do some changes here. That's what I have done here. Maximum underscore depth is equal to 5. Right? If we can remove this, we'll run it. We will predict. We are asking new thing. See here, it changed. So these are the weapons what we have in our hands to improve the accuracy of your model. Why we are checking accuracy here? Because you have, when a new person comes, you should be able to showcase to the person saying that my model, you should be confident enough, right, to tell him that these are the situations what we have come across here and the accuracy is only this much. So why did we use all this? It is nothing but we are allowing the tree to fullest. That's making the tree take long time so that it will not terminate quickly. It will not terminate quickly. So what you should do, what techniques you should use to improve your accuracy of your model. You want the best model, better prediction, better decision tree. So that's where pruning comes into picture. right? When you use this pruning, when your model is working very, very good, when you are asking it to learn patterns, but when you're asking it to learn, to test on totally new data, that situation is worst. So this is nothing but, like yesterday we have discussed, it is overfitting. So you are limiting your tree to maximum depth, right? That is done using pruning. How you are limiting the maximum depth? The parameters, what we used here, it is a CCP underscore alpha. It is called as cost complexity parameter. Pruning. Okay. Implementing a full tree and restricting it to a limited depth, right, is one of the point what you have to think of before the tree will grow to the fullest. Sometimes it could be advantageous, your model may work absolutely fine. Sometimes it could be disadvantage also. So what is pruning? Pruning is a technique you want to make your model learn better patterns, make your model learn what you call it as give better predictions is your aim. So it will the pruning also simplifies the decision tree by removing the weakest rules. It's a technique which simplifies the decision tree by removing the weakest rules. So post pruning is something it's pre-pruning, where it will stop the tree before it has completed classifying the training set. So post pruning allows the tree to grow totally. Then you'll realize that we should do some technique here to leave the tree from growing. So pruning starts with an unpruned tree. It will take sequence of subtrees and picks the best one through the technique, whatever we choose here. Right? So the best thing here is we are using CCP underscore, which is a cost complexity parameter here. Okay. So what if your decision tree is not working fine? What if your decision tree is not working fine? What we will do? We cannot restrict ourselves when your tree is not working fine, right? So there is an extension of this which is called as random forest. What is this? As we have so many trees in the forest, here random forest also has so many decision trees, right? So many trees in it. So what we have to do here, when you want to work with such a scenario, we will not restrict ourselves to the decision of one decision tree. We will restrict ourselves to multiple decision trees, where you call it as a random forest. So drug discovery research organizations, they are building capabilities for measuring and drug-like properties. They'll not resort themselves to one type of tree. There is something like structure property relationship data complement, that is SAR information. This strategy, this pharmaceutical profiling strategy, enables them to plan and to experiment or discovery done according to the drug. They don't restrict them to one particular classifier or one particular algorithm. Right? So what we have to do? We will go with something called as random forest. So it is nothing but a combination of decision trees. For example, when we are sick, we have went to the hospital clinic and we have explained the doctor that Mr. A has explained that I have some YXZ problem. So he has prescribed a medicine regarding that. It's a prescribed medicine. Okay. Then what happened? Then I was not happy with that. I did not agree. This is a perfect medicine for me because, you know, friends, whatever medicine any other doctor gives you, it is not right sometimes, because if a person is, for a few people, we see that they have some no blood pressure, no diabetes, no cholesterol levels, everything is fine, but still their body would not work with antibiotics. They totally, once they take any diabetic for any leg pain, maybe people have crossed 50 years of age, if a small pain occurs or a crank occurs in the legs also, if they have to restrict themselves from taking antibiotics, because any medicine would not work. That's the reason that when you're traveling from one particular place to other particular place also, we have to take out the diagnostic reports and also the details, whatever medicine you have been taking previously. The same way, now Mr. A again went to WXY doctor. Right? WXY doctor. So he gave different medicine again. Different drug. You did not, this is alert, this is also different. What is this? Again, you went to some other person who is CDB. Right? One more medicine. So out again, one more doctor. Right? We are giving another drug. Right? All the four. So what is going to happen out of these four? Number of times the more repetitive medicine is there, that is a conclusion. Right? This is a conclusion. Okay. So this is, if this is C, this is A, is Silamet, it is metoprolol, or you are giving him a dolo. Again, it is Silamet. So if one is giving for hypertension, one is giving for fever, one is giving for low blood pressure, right? So whichever is repeated maximum number of times, that is your conclusion. That's how random forest will work. So different decision trees, random forest is building decision tree 1, decision tree 2, decision tree 3, decision tree 4. Right? So decision tree 1, decision tree 2, decision tree 3. This is giving drug. This is giving drug. This is also giving output as drug. If it is A drug or B drug, A drug or B drug, A drug or B drug. So what is happening here? You are deciding this and you are selecting the majority of them gave which drug, that is your output. This is a solution. This works the best than your decision trees. But the underlying concept is decision tree only. But because it is not restricting on one decision tree, multiple decision trees are there, then it is random forest. It is random forest. So the extension of decision tree is this. The extension of decision tree is your random forest. So random forest is very, very fast. It gives you very good model, right? It gives you very good results when compared to your decision trees. So these decision trees are most popular among all the new statistic learning methods, right, which are being used in the pharmaceutical industry for predicting quantitative structure activity relationships. So what is that you should do here is, our aim is relevant inputs is what we have to take. If the inputs are given relevantly, we have to give it to decision tree. Decision tree will work accordingly. So what is that? If the decision tree is not performing well, then we can move forward, taking forward our random forest. Right? Random forest. So what is random forest going to do? Random forest will not restrict itself to one decision tree. It will take multiple decision trees can be built, which will help you to give a better model. So classification, diagnosis reports, taking that there are many situations where decision must be made effectively and reliably. So conceptual, simple decision-making models with the possibility that, automatic learning, they are the most appropriate for performing these tasks. So effective decision-making technique with very good high classification accuracy, with simple representation, right? We are using this decision tree. So making the right decision tree is becoming a key factor for our any of the business problem. We have to achieve the goal. So decisions play an important role here in medical diagnostic processes. These decision support systems, they are helping the doctors, the physicians, they are becoming a very important part in the medical decision making, where decision must be effective and it should be reliable. So some decision making models, one such model is this. One such model is our model, what we have built. So when we are trying to find out a solution, right, we did not stick to one particular input. We have taken multiple inputs. We have taken multiple inputs. So what is that we are trying to do here? We are also testing it without, any flip side occurrences after you build a tree, right? So for predicting such things, definitely if you are not tuning the parameters properly, you will have to end up with wrong prediction. So what we have to do here, we have to go for random forest, right? So this is also helping you in drug discovery. So what is the process it is doing? It is a divide and conquer rule. So the decision tree paradigm is something is done where you're splitting the data set into some homogeneous subsets through some rule, which is nothing but the rules are nothing but the classification rules. So whether it is a numeric prediction or whether it is anything which is classifier, so this drug discovery is something what we can do easily with respect to this decision tree. So both random forest and decision trees are the two examples. Only implementation is different. Probably both are good, but random forest gives not restricting itself to one decision tree. Right? Sometimes what happens, your Food Drug Administration or your National Center for Toxicological Research, they does something different. They rely on small sample of complex tree building. So what is going to happen here? This is something what you are going to do. So random forest can work as a powerful feature selector. So many features we have selected here. These features, out of which how many are correct, how many are not important, is what we are trying to find out through decision tree. So it is nothing but it will give a very, very good classification than any other network or any other model building. Right? So when you go deeper and deeper, the tree is going to the fullest. We have to take here a situation where sometimes your model will give wrong insights because you have taken unnecessary clutter is taken here. Right? Unnecessary we have taken, these are not important, maybe only few things are important. So which is helping you to select the right features. So I might have collected a patient's data with all these inputs also. I did not take it. Why? Because my tree did not take those inputs. It felt that they are not important for prediction of this particular medicine for the given inputs. Right? So when it is pharma requires, a strong element of human intuition here. Right? If at all you have very, very high fever, which is accompanied by a very low blood pressure, right? It can be caused by myriad of some factors. So making accurate diagnosis is as much as an art. It is very, very important, like just science. So what will happen now? The algorithms are very, very great that they are identifying the correct one. How it can differentiate from a common cold or a common blood pressure level, and why that potassium is only important here. Right? So in pharma industry, it has scored some notable success in applying this decision tree algorithm for many real-time use cases. Right? Whether the concept of all the concepts related to data mining, right? We are working with Python, where you are able to get the right predictions. Right? So there are few things where these are good enough. Right? You can also find some risk-based monitoring systems in your trials also. So something can be good. Sometimes it is good to use decision tree. Sometimes maybe it is good to use a regressor. Depends upon your business problem. Right? So that's it for the decision tree here. So it is a top-down approach. It is a divide and conquer rule. It is a greedy algorithm. It calculates information gain. It strips the branches based on a criteria called as entropy, right? And you have a concept called as pruning to get a very good accuracy. If pruning is also not happening, and you can go with random forest. All come under single family. So whatever the concept we have studied, we can apply them in a better prediction model. Occurrences can be calculated in a good way with good accuracy. And friends, a gentle reminder, the question is posted in the YouTube link. Right? You can just answer it. Right? So that's it from my side. Thank you all for joining in. Thank you.